Hello, so today I'll be doing search in 2D matrix. It's the medium one on LeetCode. So you're given an m crossing matrix with following two properties. So basically, each row is sorted, and then the next corresponding row is also larger than the last element of the previous row. So it's sorted like this, and then like this. So and then we just have to find an element in this. So given that we must write a solution in log of m cross n, which is number of rows and columns. So the first approach we get in mind is basically the brute force approach, that we just do an iteration in two for loops and just find the element. The time complexity of that would be m cross n, which is not sufficient. So it's given that we need to do it in log m times n. So for one approach, which is a better optimization, which I can think of, is basically just do a binary search on this row. If you find the element, stop it. If not, move to the next row, do binary search on this. If you find it, stop it, or else next row. So this is also not so efficient. It is n times log of m, which is number of the time complexity. So it will be of n times log of m. Okay, so the best, but however the best, so the most optimal approach would be, actually, if you look at the matrix, you can actually think of flattening it into a single 2D array. Not actually 1D array, not actually flattening it, but just it's like a representation, right? So it's given that it's sorted like this. So 1 3 5 7 1 3 5 7, and then 10 11 16 and 20 over here, then 30 40 60. So it's a single array which is sorted. So we can just do a simple binary search over this. So we can take low as here and high as this at index 11. We get mid as 5. Calculate mid as low plus 5 by 2. Mid is 5, index 5. So here comes the trick. So the trick is, since it's a 2D array, we can't just access it by mid, right? So we have to find out the row and column of that element. So there's a simple formula. To find a row of that element, we have to just take the index, that is mid of the current element, divide it by the number of columns, that is m, you get the row. And for the column of that element, you have to just modulo that index with the number of columns, you get row and column. So example, if you do it here, you get matrix of row and column is 23, which is the target you're looking for. So you can just code this approach. So put int low to, just take int n equal to matrix size, which is the number of rows, int n equal to matrix 0 size, which is the number of columns, and int equal to 0 and I equal to n times m minus 1, which is basically the last possible index, that is this one. So yeah, while we do simple binary search with I calculate mid plus 2. So this we just low plus high minus low, we do it for to avoid no buffer overflow error or memory overflow error. So in case if you have low as int max and high also has a number like maybe a little smaller than int max, if you add them up together, it will exceed the int max memory. So we just do this to avoid that. So we find the row of the element currently which we are looking at, it row equal to m, which is the number of columns, mid divided by the number of columns to get a row, and columns as we get as mid modulo the number of columns. Yes, and let's check if matrix row and column, if it is finds the element, it will return true, or else matrix column is less than the target. That means you have to search in the left half of the array, so just high equal to mid minus 1. Yes, and then if else low equal to mid plus 1, just in the next right half of the array, and then just return false if you didn't find anything else. Let's see, it should be return true over here. So let's see. Getting wrong answer over here. Oh, sorry, it's my bad. It should be the other way around. Low equal to mid plus 1. So if the current element is less than the target, we have to look in the right half, right? So we just do mid minus 1, and then here it was high equal to mid plus 1. Should work now. Yes. Submit it.